Hello everyone, welcome to Nrcm. This is Shravani and I am going to explain operating system of Unit 4 and the topics are Contagious Memory Allocation. So before going to the Contagious Memory Allocation, what is Contagious Memory Allocation? It is a memory partitioning technique. Okay, so the memory will be partitioned. The main memory will be partitioning in two ways. One is single partition allocation and second one is multiple partition allocation. So in single partition allocation, what happens? The main memory will be divided into two different slides or two partitions. So and in the low memory, this operating system will be residing and user process which are held in the higher memory like relocation register used to protect the user process from each other. And here it contains the base registers. In single partition it contains the base registers. The value of the smallest, the base registers are nothing but they contain, the base register will contain the value of smallest physical address, and the limit registers will contain the range of logical address, and here each logical address must be lesser than the limit register, and memory management unit, it maps the logical address dynamically. But this is one kind of the partition, but in single partition the disadvantage is we can say like it has like it cannot support for multi-programming. So if you want to support, if the multi-program need to be supported once, then we need to go for the multiple partition allocation. So, and this multiple partition allocation, it has been further divided into two more types. So one is contiguous memory allocation. So here comes the contiguous memory allocation. It is used for achieving multi-programming. And within this contiguous memory allocation, there are two types. One is fixed partition. So this is the fixed partition, and second one is the dynamic partition. So now let's see what is fixed partition. So fixed partition is like, as the name itself indicates, fixed. Okay, fixed is like not changing. So here main memory is divided into a number of static partitions at system generation time. So a process may be loaded into a partition of equal or greater size as shown in the diagram. Okay, so here you can see like the operating system, it has been like arranged like equal. So here it has been, so all are like if the partition is like all equal. So the process may be loaded into partition with equal or greater size also. So here the partition, it is starting operating system with 8. Okay, the partition starts with 8. So here it can store equal or greater than. So if you see here, so here you can see like, so it starts from 2, 4, 6, 8, 8, 12 and 16. So it can be like equal or larger than the or greater size. Okay, so here the maximum number of active process will be always fixed in size. They always will be in fixed in size. And the simplest partition method is dividing the memory into several fixed size partitions. So dividing this several fixed size partitions, it is called as fixed partition. So here each partition may contain exactly one process. It contains exactly one process. So and here, like I showed in the diagram, the 64 like memory, it has been divided into 8 equal size partitions with 8 megabytes each. Okay, as I discussed. So if any of the process whose size is less than or equal to the partition size, it can be loaded into any partition available. Okay, if it is less means then uh, we can combine them, and we can make it equal. And when no partition is available and a new process is to be loaded, the process already residing in main memory may be selected to be swapped out to free the partition. So hope you all understood. Like just if this is a main, there is no space. If this is full, this is full, and one more new process has been arrived. So with some partition or like with 8 only, one more process has been arrived. So but here no space at this time. So some of the page, some of this it will be swapped out, and this new process will be swapping in. So the advantages are like, so the advantages we can say like it is simple to implement, and the disadvantages are like operating system like inefficient use of memory, and because it has some internal fragmentation. So because of that, so there is this shows a disadvantage. So and so if you see this, like I can say this is your operating system, it is in 8 megabytes, right? So I'm sorry, so this you can take it as fixed partition, and this is like non-fixed partition, or you can say unequal size partition. So this can be like unequal size partition. As you can see, so first it has 8, and then 2, so 8 megabytes, and then 2, and again 4, and again 6. The sizes varies, right? So 8, again 8, 12, 16. So this will be, this you can consider it as unequal size partition. Like as an improvement, so if you want to show the improvement for this, unequal size partition, it may be configured in main memory so that small programs will occupy small partitions, and big programs are also likely to be able to fit into the big partition. Although this may solve the problem about, this will solve the fragmentation problem. So this might solve the fragmentation problem. So if the memory is just fixed, consider if this is not used, this whole 8 megabyte is not used, so here this causes the fragmentation problem. So sometimes this might require 8 megabytes or even lesser than. Okay, if it requires greater than, means anyways it has been equal, so it will be it has been splitted, that doesn't matter. But if the file or if the process requires less than this 8 megabytes, so then this causes the like fragmentation problem. So here equal size partition to some degree, the fundamental weakness still exists. As I said now, the number of partitions are the maximum number of the processes that could reside in the main memory at the same time. So when most processes are small, the system should be able to accommodate more of them, but fails to do so due to the limitations of the fragmentation. So here I just want to give fragmentation. In fragmentation, there are two types of fragmentation. So first one is like external fragmentation, and second is internal fragmentation. So in external fragmentation, like the total memory space exists to satisfy a request, but it is non-contiguous. Internal fragmentation means allocated memory may be slightly larger than the requested memory, but the size difference is memory internal to the partition but not being used. So reduce the external fragmentation by compaction. So we can reduce it by compaction. So compaction is nothing but it shuffles the memory contents to place all free memories together in one large memory. Compaction is possible only if reallocation is dynamic and is done at execution time. This is all about fixed partition. So, and I have discussed about the advantages, disadvantages, and fragmentation regarding external fragmentation and internal fragmentation also. So in external, so like a total space exists to satisfy requirements. So there will be extra space, but it is not contiguous. The space will not be contiguous. So if this is some extra space, this is full, this is full, suppose this is full. So the extra spaces are, it is not contiguous. Here there is some space left over, and here there is some space left over. This is called as external fragmentation. And coming to the internal fragmentation, it has been allocated. Okay, it is allocated. So but here what happens, this is full and it needs some more extra. So here you can allocate maybe slightly larger. So the data may be slightly larger than the requested memory. So this is called as internal fragmentation. Okay, next moving to the dynamic partitioning. So as the dynamic partitioning, like here the partitions are created dynamically so that each process is loaded into a partition of exactly same size as the process. Here the dynamic partition, it happens like this process size will be equivalent to this partition size. If how many processes are there here? 4 processes are there, and the partition will be like into 4. Okay, and here, so when the new process is created, what happens? The exact amount of memory space is allocated to the process. That we all know that. Similarly, when no enough space is available, and a process may be swapped out temporarily to release the space for new process. This happens here. So if suppose consider like one more new process arrives. Want to show. So if any new process arrives here, so consider that is so if the new process arrives, so there are only 4 processes, no? So consider different process, that is P5 arrives here. So then next what happens? This is process is full and this partition is also full. So then what happens? Some of this partition, some of this process will be swapped out, and then next this will be swapped in. Okay, this is about the dynamic. So it will be extendable. And so means swapping will be done. Swapping will be done. This will be entering and the other one will be coming out. So here the, like you can see, like advantages are like, I feel like no internal fragmentation as discussed with previous slide. Here it won't have any internal fragmentation, and it is more efficient to use. Here main memory will be used very efficiently. And the disadvantage is like inefficient use of processor due to the need for compaction to the counter level external fragmentation. So that will be the disadvantage. And I hope you all understood the topics which I have explained today. I'll be coming up with the next video. Thank you until then.